Hello, I'm going to do this LeetCode hard question for median of two sorted arrays. Given two sorted arrays nums1, nums2 of size m and n, return the median of the two sorted arrays, and the result should be with the time complexity of log m plus n. So this is apparently a binary search. So the next question is what we are searching for. The question is asking for the median, which is value in one of the nums1, nums2. But the definition of median is decided by the index, basically the middle index when you merge nums1 and nums2. So once you find the median, the length between nums1 and nums2 has certain properties, and we can leverage on that knowledge to search, to do this binary search. So if nums1 and nums2 merge into nums3, then this median exists somewhere in this nums3 that divide both nums1 and nums2 into left and right. So you will have left 1 from nums1 and similarly left 2 from nums2 and the right 1 from nums1, etc. So what we already know before knowing where the median is the length of left 1 plus the length of left 2 is always equal to the where the median is. That's one thing we know for sure, no matter where the median will land. And the second is we also know the last one, the max value from left 1 and the left 2 should always be smaller than the minimum value from right 1 and right 2. What this means more specifically, because we already know left 1 must always be smaller than right 1, since you get them one by one in order from nums2. So what you can derive from this conclusion is the max from left 1 should also smaller than the mean of right 2, and similarly the max from left 2 should be smaller than the mean from right 1, and if that is not the case, then you should keep searching. So that's what we know for sure. So for binary search also you need to define low and high, since the meaning of so first what we are searching. What are we searching? It is the length of nums1 in the left. So that is, we call it left 1 here. So it can be 0, which means on the left side there's no number comes from nums1, or it can be just the length of nums1. Let me define here first. And we also know the median, the length of the left side of the median should always be the total divided by 2. I will put if the total number is odd, I want the middle number to be on the left, and I can show you later. I will show you later. It's okay if you don't have this. It's just when you return the value, you need to take care of that. Yeah, that's all we needed. Then we can loop to find this value. So the needle, which is this left one we defined here, left side from nums1 is the binary search, the middle of all the possibility, which is low plus high divided by 2. And the left, this leaves the numbers from nums2 to fix the value. Now we can discuss those two situations. When they are not met, we need to keep searching, otherwise we find the result. So the first situation is the needle, or the left one, is too small. The second situation is left one is too big. If it's not too small, not too big, we found the result. So what's gonna happen if left one is too small? If left one is too small, that means there will be more numbers from nums2 goes to the left, and so that means the ending of left 2 will be bigger than the first value from the right side. Basically, it will break this rule. If the last value from nums2 on the left side is bigger than the first value from the right side and nums1, then this shouldn't happen if this is the real median. So, but now this happened, then that means we should keep a search, and we should update the length, because this is where the left is too small. This is a derivation when the left one is too small. Then we need to increase it by updating the low. Another situation is the opposite. When the left one is too big, then that will break this rule, because the ending of left one will be bigger than the beginning of the right side from nums2. Then we should make the number smaller by updating to the current value. Otherwise, we can break. And one more thing is, it's possible to break this index if you don't check it. So you want to add the condition where left one smaller than its possible value, which is L1, and this one, because it's -1, you want to make sure it's bigger than 0. And you can do this check on nums2 as well, but you want to do this check on the nums that is shorter, because it's more restricted in that sense. So you always want to add if length of nums1 is bigger than length of nums2, then you want to swap them. So if you did the opposite thing, if you check if length of nums1 is smaller, then you swap, then you can do the check on the nums2. Basically, you always want to check the smaller one. So now we get the value. Now we return. When we return, well, there are two situations where when it is odd, the total of L1 plus L2 is odd. Since here is where, like, the only place this matters. Here we decided we put this extra middle value to the left. Then when it is odd, you want to just return the left side max value. And if you do this way, then the middle value goes to the right. Then you will want to return the right side mean value because it went to the right. But I'll go with this way. Either way will work. So let's check the left side boundary, which is the maxi. This is why I want to do this way, because this way it's more natural, because you go left to right rather than go right to left. So the left max equals the max value between the last number from nums1 in the left and the last value from nums2 in the left. And this is ideal situation or regular situation, but it's possible that there's no values on the left from nums1. If that is the situation, if left 1 equals 0, then the LMX can only be from nums2. And similarly, if left 2 is 0, then this value has to come from nums1. And the rest is the regular case. So when you get the left side max value, you can return immediately for the odd situation, because the middle value goes to the left. However, if it's an even number, you also need to calculate the right side and divide them. So similarly, you need to consider the two situations where all the right side only comes from one array. So this is the first value from the right side from nums1. This is the first value from the right side from nums2. So if all right side from nums1, then that means all nums1 is used up in the left side. So we want to check if left 1 equals the length of the whole array, then it is used up, then we have to return from nums2. And similarly, if left 2 is used up, then we have to return from nums1. Otherwise, we can return both. And now we get left and right, so we can just return. Since we already handled the odd situation, now we only need to handle the even situation. where you divide them. So maybe there are some typo, but when you do this question, just because this direction matters to this check, so that's one thing to be careful. And another thing is where you decide to put the middle value. If you put the left side, then you return the left side max value. If you put the right side, which is without this one, then you return the mean value from the right side. Either way will work. You want to be clear how the code works exactly and stick to one pattern so you don't mess up. Left 1. Left 1. That is a lot of typo. Yeah, that's all. I can show you very quickly. Like when you change this value, you just need to return the left side first. By the way, you always want to handle the odd value of odd situation first, because odd you only need to return one value, even you need to return both value. So if it's odd value, you want to return this left side mean value because you put it on the right. Otherwise, you want to return their left side x plus divided by 2. Yeah, so it doesn't matter here. That's all. Thank you.